Thank you very much, Anna. Welcome back. So I'm checking my time. So my research is in software engineering. Specifically, my passion in research is on software architecture and how it relates to sustainability. We typically tend to link sustainability with Mother Nature and ecologic issue. Now the things is changing, and as we know, especially for the digital society, sustainability can mean a lot of many other things. What I would like to focus in this talk is basically to think about what does it mean to develop software when we have this sustainability intent in mind, and what real challenges for future research in my field, so as related to software architecture and software engineering, does it bring? First, 2 pointers. Well, my passion is software engineering, software architecture, and sustainability. So we try to bring these 3 elements in both education and research. In research, this is a pointer to our research group, so feel free to look to that, to link to that. And in education, we have a master in computer science track in software engineering green IT, which I like to believe which is very unique. So we try to bring together industry and public sector with students and research so that we form a future generation of software engineers that bring sustainability also to practice. Now to the point. So I collected here almost randomly 3 examples of what I call projects. So these are types of application which, in my personal opinion, could exemplify what does it mean sustainability in a digital society. The first one is a great initiative, I think, a little bit futuristic maybe, which is in the middle of the North Sea in Dogger Bank. There is this consortium of different countries that plan to build an island. So in the Netherlands, it's not just big news. We build country while we have sea. But in general, the idea is really to have a hub for these great wind turbines parks, so that we bring green energy, green electricity to about 80 million people, anytime, any place. All together with houses, airports, organizations to actually hub all this electricity and redistribute that. The second project is about smart mobility. So being able actually to work or do activities anytime, anywhere, decide to travel or rather untravel, so travel virtually. And also to have autonomous traveling or transportation, which allow us to do something else while we are traveling, which opens big opportunities to different societal models, different way of lifestyles, and different businesses. And the third example is smart healthcare, in which we hope that this helps us in becoming healthier and live longer. So the point here is, what do these projects have in common? So we might have different opinions and different angles depending on our expertise or what we like or dislike. But from my perspective, maybe obviously so, they all have in common software. So there is a big reflection point here for me, at least. The reflection point is that there are 2 big assumptions in a digital society exemplified by these 3 projects. The first assumption is that we believe that this is what makes society a better place. So we build software and cyber-physical solutions with the intent of improving our society, improving the way we live, having a more sustainable environment, etc., etc. So in order to be able to do that, we assume that we monitor the extent to which we improve. So we reach this goal, which leads us to being able to estimate forecast and measure that we are nearing our target, which is not always that simple, as we will see in a short time. So the second assumption is that software is there to make this dream come true. So with the way we engineer systems is thinking that we have an architecture of a system, we know it up front, more or less everything, or we make assumptions about this architecture, and then we develop systems that allow us to make it reliable, independently from any unpredicted change that will happen over time and space, in collaboration with an increasing number of other organizations and stakeholders that have their own software and their own assumptions, their own architectures, and they have different types of intents. So this makes the whole picture of assuming the software is there to realize the dream, but very complicated and rather complex. So software engineering, in my opinion, is still very mature to actually realize this wish for a digital society as we think or we want to plan it. So this leads to me to say, what do we mean with software intent? It's not a requirement. Software intent is the fact that we have pieces of software that change over time, are supposed to change and still work correctly, reliably, and satisfying a certain goal, independently from what happens. Keep us safe, protect economic goals, etc., etc. So this resembles a little bit what Asimov defined with the three laws of robotics. I don't know if anyone is passionate about Asimov, but this goes back to the 40s. And basically, these laws say robots will not harm or cause harm or allow harm to human beings, will protect human beings, and will protect themselves, exactly in this order. So in a similar way, we expect software to be resilient to bugs, be resilient to attacks. We expect software to actually protect social concerns, etc., etc., independently from the situation, independently from the context. So this is quite a challenge. So in sustainability, we have many different elements that make this picture even more complex. First of all, we have different types of dimensions that play a role, not all of them simultaneously, but almost all of them in any type of digitalization project we can think of. First, we have environmental concerns to preserve ecological environment, social concerns to make society and the interest of human beings and organizations address them, so social communities. The third one is to support economic return on the investments over time. And a fourth one is what we typically are comfortable with in software engineering, which is technical type of concerns. Security, reliability, usability to some extent. So these four different types of concerns play together a role for sustainability. For each type of projects, the challenge for us is that for each of these four dimensions, the type of concerns change. They are not the same. Even more so, what we have to measure to assess that we reached a certain target also can change. So we don't have one standard solution in which we say, okay, if we measure these four types of concerns with this type of metrics, then we are sure that this sustainability intent is realized in a certain project. So this is very ad hoc still, which is a threat. The second aspect is that we tend to think about sustainability as something that has a certain impact in one project, more or less now or in the short term. Instead, the notion of sustainability is something over time. So it's not that now I have an economic gain by selling a certain software app. It's that this software app, over time, will help elderly people in becoming healthier, not forgetting their medicines and how many medicines they have to take every day. So, which means that we have not only to think about the immediate impact of a certain software product we develop for the project, but also we have to reason about what is the enabling impact in the short to long term, and what is the systemic impact of the very same software that we develop, which means what is the long term, maybe outside the scope of a certain software project, but what is the impact of this software project on society at large. So this is a simple example. I don't want to enter the details. This is smart lighting, which everybody more or less knows, allows for cities to actually tune, depending on the behavior of certain quarters in the cities, to tune certain solutions about lighting. So typically, in the short term, smart lighting has two main concerns. One is technical. The software solution must be configurable so that we can configure the solution differently per quarter, depending on all types of behaviors in that quarter, topology of the streets, etc. The second is about energy savings. After all, we want to switch on off lights to certain grade, to certain level, to save electricity. But we see from this picture that we have other impacts. For example, immediate impact of being able to have this different configuration of the solutions has positive impact on well-being of the people, which is proved by certain projects in which sleeping patterns and eating patterns of people improve in countries where you have not so much light across the year, and then this helps actually in improving their level of health. In this case, we see that the systemic impact, which is totally outside my own project for smart lighting, is that this will cause a positive impact on healthcare savings, because people are healthier, and obviously the government has to invest less in healthcare because it's less needed. So this is a kind of hypothetical scenario in which we see we could address the direct impact of a project in a certain point in time, but if we are able to foresee or at least consider in our development also what we enable and what is the potential impact on the system, the systemic one, then we are able also to cope with sustainability over time better. And this is not done, at least in software engineering. So if we are able to do that, we can have sustainability being cost-effective over time. We can have become more socio-technical savvy over time. We can be eventually energy neutral, etc., etc. So this means that we must able to control, for instance, the transition from being energy aware with this software solution for society to being socially aware. I like to mention one example, which is fancy but not very practical, from Mission Impossible 2, in which we have a nice hike and then I'm able to have a phone call. Well, it's nice. Maybe you don't want to do that if you are in such nice environment. But there are more, let's say, urgent problems, like, for instance, in the middle of India or Australia, in which you want to reach people because of healthcare situations, emergency situations, or simply any type of support from open digital governments. This means that you have to cope, in this case, with resource-scarce environments, being able to deliver this software solution when resources, connectivity, access to the cloud, etc., is not always available or is more challenging. The second is connected to smart homes. That is a notion that is useful for many different types of scenarios. In this case, also, we might have scarcity of resources, or you might have people that are not so comfortable with technological solutions, like, for instance, healthcare for elderly people in smart homes. And then you want to be able to reach out to them easily and effectively. So how can we do that? Well, we have a lot of techniques in software engineering, for instance, making available software practices that make these solutions more energy efficient, but also partial design solutions like patterns and style, which are pieces of the architecture that prove to be actually effective in different situations. For instance, in making available an alternative type of cloud when I'm in the middle of Africa in the field, and still I want to know the weather situation to be able to cope with my field for farming. So these reusable situations, patterns and design solutions do exist, but they are not actually made available. So one aspect of digital society is open access to knowledge and open access to resources, and this can be quite easily actually made available also for software engineering. So making these software practices both for implementation and design available. The second goes back to being able to measure the extent to which we actually achieve our software sustainability intent. We have a lot of techniques that are historically meant to measure, so for instance, empirical methods in our field, to measure precisely and while limited, for instance, threat to validity, so the risk of biases and influencing results of the measures. These are very nice, but they require a lot of time, they are very slow, and they are hardly generalizable. So a good, let's say, open research problem is how do we make these measuring techniques faster, maybe less precise, but thanks to the increasing availability of data, we combine the lack of generalizability or precision with the amount of quality data, which is data that we rely for being trustable, and that we use this data actually to achieve faster types of measures that build, back to the previous challenge, knowledge for building faster and better these software solutions. This links also to a lot of initiatives that try to achieve what is called green labels. So we have labels of many products, and we use them to decide if one product is good for us, for instance, among other concerns, consume less electricity. Green labels are a challenge because we need all what I said before in order to predict the impact on quality, for example, energy consumption. And if we are able to do that, we will label, for instance, one app to be more or less energy savvy, independently from where I install this app, in a tablet, in a certain brand of the smartphone, etc. But actually, green labels are not only just about putting a standard on a product, software or not. Green labels are about creating awareness in the users so that the users are more engaged in actually the impact and the use of these apps for different products in the digital society. And again, engagement is one of the prerequisites and assumptions for achieving a digital society. We are always talking about addressing goals which are around the users, around the citizens. So we cannot forget about that. So back to the other dimensions for sustainability. Smart software is also supposed to go to create business innovation and needs technical breakthrough. For instance, when we talk about smart mobility, I mentioned before traveling and untraveling. Actually, untraveling means that every day I can decide dynamically if I go to work or if I'm a student, where I'm going to study, how I'm going to study is online, do I follow a lecture, or rather have a Coursera course in which I have another type of interactions with the other students that virtually attend the same course. So we can dynamically decide what to do in any type of situations. And the assumption again here is that the software allows us to dynamically patch together or connect together services or components that form the software solution that supports my choice. So you have a lot of challenges. This dynamic composition means that the software has to adapt to my needs as a user, which is not an easy task. There are some techniques that allow to do that, but to assess that this will be reliable anytime, in any place, when dynamically I patch services from any type of stakeholders that offers these services in a certain point in time, that's a challenge. And the same, or even more so, if we think about connected driving, in which it is more tangible and evident that the primary goal here is actually safety. So all in all, in these two examples, what we need is being able to support self-adaptability, which was mentioned also in the talk before, and a similar concept called CyberForaging, in which we are able to forage resources, being these electricity or being these a certain cloud provider or cloud service, anytime, any place. And we are able to connect these resources dynamically. So this is just one of the many examples of tactics that allow, for instance, for CyberForaging, in which you have three elements. Typically, you have a mobile client, and you want to save battery life, for instance. And then you decide dynamically, well, I want to do this type of activities for my learning experience today. So dynamically, you either connect to an enterprise cloud, or if connectivity, for instance, is not so optimal, you want, if you're lucky, to connect to a nearer cloud services, nearer to your physical place, which is called surrogate. So there are many techniques that allow you to actually technically combine all these activities and make this dream of untraveling actually true. In software architecture, when we think about all these scenarios, which are very exciting, we assume implicitly that we know the type of architecture we are talking about. We know only the piece that we are in control of. But of course, if we have to connect different services from different type of parties, public sectors, service providers, etc., electricity providers, then we don't know how they work and the architecture they have. So a challenge for our field is to be able to foresee how we can create new architecture not dependent on the structure of the software, but dependent on the changes that happen in the context. So the context is changing every time, and then we have to be able to develop this intent independently from the technical details, but also resilient to any type of change. Of course, this is a major challenge that is overarching all the others. So, in my opinion, there are at least 4 types of challenges that I experience every day in my work, that to make software supporting digital society in becoming more sustainable. Open access to the knowledge that we develop every day and we don't share. Being able to measure and create these green labels for engaging the users of this software or the organizations that use or consume this software. New methods that allow us to monitor the extent to which we achieve this sustainability intent, and then being able to create new type of architecture for this complex software that relies on changing in the context, but we don't know completely, so we have only a partial knowledge about these architectures. So today in the Netherlands is election day. I'm here luckily or not, you can judge, only because I'm an Italian citizen, so I'm not allowed to vote. Otherwise, I was in the country. But I will mention this because Rutte, the prime minister, until today at least, he said once, or recently actually, tax reductions are not for free. And anybody that says that tax reductions are for free, or don't mention the implication of reducing taxes, is lying or hiding the truth. So we can argue what is the difference between the two things. But anyway, in a similar way, I think, if we think about digital society and we don't think what are the challenges to make it, to realize it, we are equally hiding the truth. So this is my message. Thank you very much.
Thank you, Patricia. Thank you. Thank you very much. So it's very interesting and very comprehensive. And we were a few minutes after time, so I'm going to allow one question. So the first one up with a hand gets a question. Who's going to win the race? Okay, I'll get it. Thank you. I was just thinking, because you were talking about these methods, and when you talked about how they actually followed the user when it came to Lightning, I was thinking, do you also combine this with methods of following behavior patterns and finding, sort of understanding the client's needs, the customer's need?
Yeah.
Do you combine this?
There are different ways of doing. One way is to actually work with pool of users, so I have pilots in which you can use, for instance, applications, and then this pool of users agree to actually share the data. So you can gather the data about how they use to certain purposes the technology, and then from this data you deduce what they can do, what they can't, and then you can create new, elicit new behavioral patterns. There are many, for instance, a pile of projects with Dutch municipalities that I know, in which they have hundreds of households and people that are part of these experiments. And then municipalities monitor their behavioral patterns and then discuss with them what they would like to do and they are not able yet. And this changes completely the role of the municipality and then the government with respect to the citizens from public sector to service provider. So this close interaction in this way of having experiments is quite interesting.
Interesting. And you come from a software background, but does that mean you work in cross-scientific teams to do this research?
Yes. So multidisciplinary research is very hot at the moment and necessary.
Very good. Thank you.
Thank you very much.
I've got a box of chocolate, and while you get it, we'll give you a round of applause. Yes, thank you.